Hello, my dear students. How are you all? I hope you all are fine. Today I am here again with a very new chapter of grade 10, that is metals and non-metals. So this is going to be the part 1 of this chapter. In this part 1, we are going to cover various content from the chapter metals and non-metals. So let us see what we are doing in this part 1 section. So in part 1 sections, we are going to cover the physical and the physical properties of metals and non-metals, and then we are going to study about the chemical properties of metals and non-metals, followed by certain properties of ionic compounds. So we are going to cover these three contents in part 1 section. Here is the small introduction about the metals, as we have already studied the metal elements in the periodic table in the chapter periodic table, where we have done the classification of certain elements which we have covered already in the periodic table chapter. If you haven't seen that video, please go through the video and you will be able to understand what is the positioning of metals in the periodic table. So metals are located on the left hand side of the periodic table, and some of the metals are present at the middle part of the periodic table. These elements in group 1 and 2 are metals, as well as the transition metals in the middle. And non-metals are present on the extreme right of the periodic table. And non-metals can be found in the earlier periods in groups 4 to 7. All of groups 0 are non-metals. I have already told you that non-metals can be liquid and gas, but metals are always solid. So let us see certain properties with examples of certain metals. Okay. So metals examples are copper, iron, zinc, sodium, potassium, gold. And what are the non-metal examples? It can be liquid or gas. So oxygen, nitrogen, carbon, helium, boron and neon are certain examples of non-metals. When we compare the physical properties between metals and non-metals, it shows that metals has a good electrical conductors, means they can conduct electricity easily. But on the other hand, non-metals are the poor electrical conductors. But metals has the good heat conductors and non-metals are the poor heat conductors. Metals are shiny. It means they show the property of lustrous. But non-metals are dull in appearance. Metals have the high density, means their mass per unit volume is higher in comparison to non-metals. Non-metals are lower in density. Metal shows the property known as ductility. We will see about ductility more later on, but non-metals are brittle. Alright, so we will see one by one how we can give or explain the reason behind these properties of metals. So let us see first property. Always remember, the metal has a metallic structure. The key properties of metals are due to its specific structure, because it has the positive metal ions and some electrons which are revolving around these positive ions are known as delocalized electrons. We have already studied about the valence electrons, the energy shells in which these electrons are revolving. So what happened in metal? No, metallic structure has these delocalized electrons which are not bonded yet, and their nucleus is not holding these electrons properly. So what they will do, they are just revolving around the nucleus. All right. So this leads to metallic bonding. Like all the metals have the metallic bonding inside them, which makes their structure stronger, rigid. These metals can be found in the middle and the left hand side of the periodic table. Now we will study more about the metallic bonding. Metals exist in giant repeating structures of positive metal ions surrounded by electrons which have delocalized from the outer electron shells. Stronger electrostatic forces exist between the positive metal ions and these delocalized electrons. So due to this metallic bonding which is present in between the positive ions and these delocalized electrons, leads to stronger electrostatic force. So always remember, wherever we discuss about ions, ions are actually the electrically charged particles, means the element which are having the charge on it. Okay. So all the electrically charged particles are considered as the ions. But if we talk about the metals, metals is actually considered as the positive ions. We will see further how this charge of positive is present on the metals only. Now, group 2 metals, basically we are taking the example of group 2 metals, atoms lose their two outermost electrons to form two positive ions. There is a greater number of delocalized magnesium, delocalized electrons. There is greater difference in charge between the ions and electrons, so stronger electrostatic attractions are formed. In summary, group 2 metals form the stronger metallic bonds than group 1 metals. So what happens if we take the example of magnesium? So atomic number of magnesium is 12. How you are going to write the electronic configuration of magnesium? It will goes like 2, 8 and 2. You can see this 2 which is present or regarded as the valence electron and also considered as the delocalized electron. What this 2 will do? This metal magnesium is going to withdraw this 2, right? It will going to lose these 2 electrons in order to make its electronic shell stabilized. So as the magnesium lose these 2 electrons, the charge will consider as plus. So always remember that in chemistry, when the element lose the electrons, it gets the charge positive. It is kind of opposite theory. Okay, so whenever the metal lose the charge, it will get the lose the electrons, it will get the charge positive. And whenever the element adopt the electron, gain the electron, then the element will get the minus charge on it. Okay. That is why due to this metallic bonding, which leads to electrostatic force of attraction, this metallic bonding, no, which is present inside the metallic elements, leads to stronger electrostatic force in them. And due to this stronger electrostatic force of attraction, it leads to conduction. How come conduction now? Conduction means flow of charges, right? Because of the delocalized electrons, because of the valence electrons which are not holded up by the nucleus of the element or the metal, they are just wandering here and there. They shows the movement, and this movement leads to conductivity, electrical conductivity. All right. Now, what is the melting and boiling points? Melting and boiling points of metals are always high because due to the presence of delocalized electrons, electrostatic force of attraction is stronger in them, and we need higher thermal energy in order to break this electrostatic force of attraction. That is why melting and boiling point of metals are stronger. Okay. Now we will consider one more property which we have already studied in the physical property of metal, that is metals are malleable. Now what do you mean by malleability? Malleability means when pure metals, most of the pure metals are malleable, which means that they can be bent or hammered into place, means we can change the shape of the metal. That means that is malleable. When we put larger pressure on them or hammer them, the metals will change its shape. The regular structure allows the layers to slide over each other. This is known as malleability. When the metals turn into thin sheets by applying larger force on them, that is malleability. But alloys, on the other hand, alloys means those metals which has a mixture, right, which are not made up of one metal element, but they are formed by different element, right? Only in the pure metals which can change into thin sheets when we apply force on them. This is the property known as malleability. Malleability, what is the chemical reason behind it? It is due to the force of attraction, the valence delocalized electrons which are being moving, right? And that is why we can change the shape of the metal. Alright, this is the chemical property. This is a chemical reason behind the physical property of metal, that is malleability. Okay. Now, why do we say that metals are lustrous? Why they are shining? There is also the chemical reason behind it, that most metals are lustrous or shiny. This is because there are delocalized electrons on the surface of the metal. So their movement leads to shiny properties or lustrous property present in the metal. So basically it is due to the metallic bonding, electrostatic force of attraction and delocalized electrons, which make their physical and chemical properties of the metals to be malleable, lustrous and also ductile, right? Now, what do you mean by ductility? Ductility means when the metals are able to form wires. We can make use of metals in the form of wires because they show conductivity, right? Electrical conductivity is higher. So we can make use of metals in the form of wires. So this property in which we can change the metals to form the wires is known as ductility. Metals are ductile. So in summary, we can understand that in the physical properties we have learned that metals are shiny, they show luster, they are malleable, they are ductile. And in chemical properties we have learned that metals have high melting and boiling point, metals can have the delocalized electrons in them, they have the stronger electrostatic force of attraction between them because they form metal-metal bonding. Alright, so also we have learned that they are highly conductors, means they can conduct electricity in them because we can turn the metals into wires. Alright, so there are some NCERT in-text questions which we can do right now, which is quite resembling to the theory we have learned now. Okay. So first question is, give an example of a metal which is a liquid at room temperature. So it's none other than but mercury, Hg. The metal which can be easily cut with a knife is sodium and potassium. So sodium is Na, potassium is K. Which is the best conductor of heat? It is silver or Ag. Is a poor conductor of heat is mercury and lead. Explain the meanings of malleable and ductile. So I have already told you, malleable means when you can turn the metals into thin sheets. And what is ductile? When you can change the metal and form wires with it. So this was the first topic we have completed from this chapter, that is the physical and chemical properties of metals. On the other hand, we have compared these properties with the non-metals, that in non-metals they are not lustrous, they are not ductile, they are not malleable, they are poor conductor of electricity, they have low melting and boiling points. We have already learned now about the physical properties of metals. Now we will see certain chemical properties. Chemical properties is basically related to the reactions, right? Where all the chemical composition of the element change, right? So as we have already studied about these chemical reactions, there are type of chemical reactions such as combination reaction, displacement reaction, right? Double displacement reaction. We have already done in the first chapter. If you don't remember, you can revise it by seeing my video from the playlist of grade 10. It is the first chapter, we have already covered it. Likewise, if we see the reactions, metal reaction with oxygen, okay, so it will form oxides of metal. So metal oxides are formed whenever the metal reacts with oxygen. But now what happened with non-metals? Non-metals usually form acidic oxides when it reacts with oxygen. Non-metals when react with water, it usually, if we will see the reaction with water, then most of the metals react with water, especially alkali metals, that is group 1 in the periodic table, and they form hydroxides As you can see, when sodium react with water, it forms sodium hydroxide and it releases hydrogen gas as well. But if we see in the non-metals, non-metals do not react with water in general, except for a few such as chlorine. You can see chlorine reacts with water to form hydrochloric acid and hypochlorous acid. So they usually form the acids only when reacts with water. And with the metals, when it reacts with the oxygen, it forms acetic oxides. If the metals react with acids, then it will form hydrochloric acid to form the zinc chloride and hydrogen gas. You can see when metal reacts with hydrochloric acid, they form this one. This is the type of displacement reaction, right? And in non-metals, they do not react with acids in the same way as metals, but can react with the bases to form salts and water. So usually non-metals react with the base and they form salt and water. We have also learned this type of reaction in which when the non-metals react with bases, they form salt and water, that is neutralization reaction. When the product is salt and water. Reaction with bases, when metals react with base, sodium hydroxide, they will form like these sodium tetrahydroxoaluminate and hydrogen gas. They usually form the hydroxides only and also release the hydrogen gas. And if we see the non-metals do not react with bases. However, some non-metals like carbon dioxide form acidic solutions when dissolved in water. So basically they will form acids while reacting with the bases. They are not going to react with, actually they do not react with bases, but they dissolve in water to form certain acids. Now, as we have already completed this chemical properties and physical properties, there is one more topic which needed to be discussed. These metals has the metal-metal bonds which have the electrostatic force of attraction in between them. But whenever the metals react with the non-metal, they show ionic bonding. Because we have already know that metals has the positive charge on them because they have the tendency to lose the electrons. That is why they have the positive charge on them. But on the other hand, the non-metals have the negative charge on them because they have the tendency to gain the electrons. So whenever these ions means these positive and negative charge elements or metals and non-metals react together, they form ionic bonding. So what are ionic bonds? An ionic bond is formed when a metal and non-metal react. Metal atoms become positively charged ions by losing the electrons and non-metal atoms becomes negatively charged ions by gaining the electrons. So this oppositely charged ions has the very strong force of attraction. This is known as electrostatic force of attraction, which we have already discussed in the metallic bonds as well, right? So now in your NCERT, there are certain elements which you have to show the ionic bondings. Means you have to show the reaction between the metals and non-metals, and you need to form the chemical formula out of it. Means there are certain questions in NCERT which ask you to give the molecular formula of so and so elements, in which you need to show the reaction between metal and non-metal, where metal is losing the electrons and gaining the positive charge on it, and the non-metal on the other hand, it's going to gain the electrons and shows the negative charge on it. So we are going to see certain examples here. As you can see, lithium is the positive, means this is the metal, and here you can see the fluorine. This is negative because this is a non-metal, right? We are going to see sodium chloride now. We are going to see the formation, or we are going to practice certain molecular formula when the metal reacts with the non-metal. So we have taken the example sodium chloride NaCl, where Na is the metal and having the positive charge on them, and because how many positive charge it will have? It has the positive 1, because how many delocalized electrons present in sodium? We are going to see through the electronic configuration. As we already know that sodium atomic number is 11. So what will be the electronic configuration? 2, 8 and 1. So this is the delocalized electron present in the sodium metal. Because it is metal, so it will consider as positive 1. This on the other hand, the chlorine atomic number is how much? 17. So what will be the electronic configuration? 2, 8, 7. Now these are the 7 delocalized electrons, right? But what is the valency of chlorine? Is the valency 7? No. 7 is the valence electrons. Valency is the number of electrons an atom can donate or accept to complete its octet. So this here, the chlorine needs one more electron to complete its octet, right? So since chlorine is non-metal and needs one electron to complete its octet, that is why it will gain one electron and have the charge negative, right? So here you can see sodium has the positive charge and chlorine has the negative charge. Now when you write this, when you show the ionic bonding, you are going to show like this in an electron dot structure, and do remember to mention the charge on them. That is why then only it will show that they are doing what? Ionic bonding. Charges bondings are taking place. In your NCERT, that is sodium chloride formation, like this you can do it. You can write the electronic configuration like this, and you can show the ionic bonding through electron dot structure. Okay. And there is one more example of magnesium. You can show magnesium chloride like this. Here you already know that magnesium has how many? Atomic number is 12. So electronic configuration is 282, and then plus 2 electrons, it will lose it, right? So plus 2 is the charge on it, and chlorine, it is going to lose, it is going to gain one electron. That is why negative 1 is the charge of chlorine. So now you can see, you can put like this, magnesium has the 2 electrons on its valence shell. So magnesium will try to show the bonding with the 2 chlorine, and you will get this Mg 2 plus and chlorine negative 2. They will cancel it out and it will form MgCl. Okay, I have conduction as well. And why? Because it has electrostatic force of attraction, and that because of the ions present in them, and these ions will conduct electricity due to their movement, right? And we have already seen why there is a high melting and boiling point. Because of the electrostatic force of attraction, it needs more thermal energy in order to break this force of attraction. So these are some of the properties of ionic compounds in your NCERT. Physical nature are somewhat have the strong force of attraction, and that is why it makes them hard, because of the strong force of attraction in them. Melting and boiling point is high because of the electrostatic force of attraction or interionic attraction, you can say it. Solubility, electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. We have completed all the properties of metals and non-metals. Regarding physical and chemical properties, we have seen the formation of ionic compounds and practice some of the molecular formula. We are going to practice more molecular formulas in part 2 section as well, and we will cover more topics from this chapter in part 2 section. Keep on learning and keep on revising. Bye bye.